Hey guys, Travis Gillespie. In the last section, we learned about how to write congruency statements. So we're going to move on to a problem and get some fresh space here to where you're asked to find the lengths of sides within a quadrilateral. Now, in the figure here, you see that quadrilateral WX, Y, and Z is congruent to quadrilateral HJ, L, and N. And it's so important for you to look to see how the quadrilateral is named, how these points are ordered. Because like the previous problem, it will help you to determine which sides and angles correspond to each other. Now, in this figure, you're asked to find the values for three variables here. Well, x is part of the length of a side here, so find the value of x, y, which y is also the part of the length of a side, and finally z. Now notice in this figure you're given three angles, one of them is missing, and over here two of the angles are actually missing. But remember, you're given some information, an element that is so critical, and that is this and this. The quadrilaterals have been named in the order that their sides and angles correspond. Now I'm going to actually look at this. In fact, I'm just going to rewrite it again. So it's in my own writing. Quadrilateral WX, Y, and Z is congruent to quadrilateral H, J, L, and N. And I'm not going to stop here because remember that important piece of information earlier from the previous video is, hey, don't let the shapes, especially on standardized tests, the shapes that they give you determine, dictate, or guide you to an answer. You redraw the shapes and let the information you obtain be your guide in finding an answer. So do these shapes have to be perfect? No, absolutely not. As long as I get the overall message and the idea. Well, I am going to change my pen though. Before I do, let's just go ahead and copy this here. And I don't have to even redraw it twice, which is nice. I'm just going to copy and paste over here. Now I've got the same shapes. They are going in the same direction, and all I want to do is redraw these and rewrite them so that all the angle sides are corresponding. So Z, Y, W, and X. And now I know that this side is X plus 6. I've got a 130-degree angle. I've got a 67-degree angle, 78-degree angle, and I know this side is length is 30, and this length is 18 here. Cool. Well, what else do I know here? Well, I can say a couple things here. Quadrilateral WX, Y, and Z is congruent to quadrilateral H, J, L, and N. Or I could say, hey, W corresponds to H here. And in fact, where is W? So W is here, so I know that H has got to be right here. Z corresponds to, well, Z corresponds to N. So I know that this guy's got to be N right here. Cool. Well, X corresponds to J. I'm going to put a J down here. And Y corresponds to L. So again, I could cover this all up and sort of visualize, hey, angle W corresponds to angle H, angle X corresponds to angle J, angle Y corresponds to angle L, and angle Z corresponds to angle N. Now, I could also talk about the line segments and visualize it, but you know what? I really like that this is already written out for us, so I could say, rather than the angles corresponding, I could also say, hey, line segment X, so WX corresponds to line segment HJ, and line segment XY here corresponds to line segment JL right here. And this helps me to visualize the shapes that are in place. Well, now I can take my image here of quadrilateral HJLN and say, okay, well, what are the values that they've given me here? What else do I need to fill in? Well, I know that I've got to put a 14 in for line segment NH. So got 14 here. Know that angle N is equivalent to 5 times Z, or 5Z. Also know that angle HJ is equivalent to 5y, and no, angle J is equivalent to 78 degrees. And it looks like that's all the information that they've given me. Well, the problem wants me to figure out what x equals. Well, the first thing that I could do is say, hey, line segment WZ, so WZ here, line segment WZ, is congruent to line segment, it's got to be HN. So I got line segment HN is congruent to WZ. I need to find out what x equals. Well, you could use this image up top, but we've already drawn everything down here, so I'm going to scroll down and just take it off the plate. And now I'm going to rewrite line segment and choose a different color. Let's say, hey, line segment WZ is congruent to line segment HN. And now the next thing that I can also say is that, hey, x plus 6, because line segment WZ is, it equals the length of x plus 6. Well, that equals 14. So all I really have to do to figure out what x equals is to subtract 6 from both sides, and I find out that x, in fact, equals 8. Now the next problem I'm asked to figure out is, well, what is y? Let's solve for y. So I'm just going to box this information up here because I'm done with it and move on to my next problem, where I'm going to say, hey, what is y? So y right here, 5y. So I know that line segment HJ corresponds to line segment WX. Well, that's equal to 30. So now I'm going to say, hey, line segment HJ, or I could say JH. It really doesn't matter which order I put the line segment in. The line segment HJ is congruent to line segment WX. Cool. Well, I know that HJ is equal to 5y. So 5y equals 30. Now all I have to do from here is to divide both sides by 5. And that should give me 6. Y equals 6. Cool, and I'm going to box this guy off. So the last problem I'm asked to figure out is what does z equal? So that is angle n is equal to 5z, and angle n corresponds to angle z, or I could look at my new image I created. Angle n corresponds to angle z. So I know that if they correspond to each other, then these guys are going to actually be congruent. And if they're congruent, they're the same size. So I could say, hey, angle n is congruent to, let's fix up that congruent sign, that doesn't look too good. It's congruent to angle z. Well, I know that angle n is equal to 5z, and this is degrees, so I'm going to put a degree symbol, equals 130 degrees. And that looks like a 2, but it really should be a z. So now the next step I've got to do is say, hey, divide both sides by 5. When I divide both sides by 5, I find out that y actually equals, well, 130 divided by 5 is 26. So y equals 26. I'm going to box this guy up. And I said y, this is incorrect. This is not the variable y, this is the variable z. So z, in fact, equals 26. Box that dude up. Well, now one final thing I might want to do is actually check the information. So x equals 8, well, if line segment ZW corresponds with the line segment NH, 8 plus 6 should equal 14, does it? Yes, absolutely. This value checks, and y equals 6. So for value 5y here, 6 times 5 should equal 30, and it does. And finally, z being 26, so 26 times 5 should equal 130. Absolutely does. So the values check out.